okay? Which was the standard like that we could count with the numbers, that we could do addition, we could do subtraction, we could do multiplication, we could do division, and then we got a little bit fancier with things like fractions, decimals, and percentages. Okay? That's where we went with that. Okay? And now, come on. Okay, forget it. Why is that just not? There we go. And then we did our unit on abstract math. Okay? And abstract math was really algebra. Really? You really want to be like that? Let's make you a little bit thinner. Algebra, okay, which was really just puzzle solving. That's what algebra is all about, is something is unknown, and you're using math and math techniques to solve for the unknown. And if you think about it, that has a ton of real practical uses in the real world. It's tough at first to think of that, like how am I going to be working with X and solving for X? But if X is how much you're going to tip someone, if X is how much you're going to pay in interest, if X is something actually real, then algebra becomes real, okay? So from numbers and arithmetic through the abstract math, now we're heading into geometry, okay? What geometry is we're going to talk about that, is also these two things. These two things apply in geometry. We are going to be using numbers. We are going to be solving for things that we don't know, but we're doing it with sort of the real world as part of it, okay? And this involves the idea of measurement, okay? And we'll look at that and what that means as we start today. All right, so let's get started. Computer is running slow, but we'll make it work. I think that was Mr. Watt. Okay. This thing gonna work? We're just gonna have spinning things here. Oh, and the recording software crashed. Really? Okay, so let's take a look at geometry. There's only going to be a few parts because of the time we have left. I won't be able to probably cover as much as I would have liked to if we had more time. Okay, let me get the lights here. So let's start with that simple question, what is geometry? I asked my daughter this question. I said, what do you think it means? Okay. What words do you know start with geo other than geometry? Geology, yeah. What else? Nothing else starts with geo. What about geography? Yeah, geography. That's it? That's all, that's fine. So what do these three words have in common? Geography, geometry, and geology. I can think of something. I'll tell you what it is in a minute. Let's look at the second half of the word. Metry. Metric. Yeah, you're right. The metric system. Okay? No, it's not a Canadian thing. We use it in Canada, but it's not a Canadian thing. So the word geo literally means earth. And the word metric comes from metron, which literally means measurement. So what geometry literally means is measuring the earth. That's what geometry means, okay? It's a branch of mathematics that basically deals with the idea of measuring things in terms of shape, size, position, like where I can place it, the properties of those things. So just like the Pac-Man game I just showed you, where we measure where Pac-Man is and then move him around, that's what geometry is. Simply put, geometry is putting numbers into the real world. So when you want to see how tall you are, you're essentially using geometry. You are measuring the earth, okay, and the things on it. And in math, we know we can change numbers. We can do all kinds of things to change them. So if we change numbers in math, do we change the measurements in the real world? Possibly. So geometry is that branch of mathematics. Okay? So this relates to how do you define something, right? Like how do I put numbers on an object? I bet you guys could put numbers on your height. Can you do it metrically? Do you know how tall you are in metrics? You might know how tall you are in the imperial system. You might say, well, I'm 6'1", or I'm 5'4", I'm 5'7". That's not the metric system. So how did they put numbers on it? And is that the only way we could define things? Okay? How else? Maybe you guys could invent your own system. But if nobody else is using it, it's a tough system to use, right? How do we put numbers on objects? And if we define it a certain way, is that enough for everyone to understand it? And if I give you a number, I say, oh, there's this kid coming in here named Sam, and he's 20 tall. Does that actually let you see how tall he is? If I don't say what 20 means, does it actually help you? You need some system that works for everybody, and that's what geometry is. So let's try a circle. How can you describe a circle with numbers? What ways could you define it? What do you know about a circle? Well, first of all, you know its shape, right? When I said the word circle, a shape appeared in your mind. Hopefully, all of you had the same shape in your mind. And it wasn't, hopefully, something, when I said circle, hopefully it wasn't this. Like I said, oh, circle. And inside your brain, all of you thought this. Okay? Probably not. I'm hoping, when I said circle, all of you thought of something like that. Not necessarily that exactly, but something like that. So when you thought about circle, maybe you thought of circle-shaped objects. So let me give you a couple. A Blu-ray, circle-shaped. A bicycle wheel, circle-shaped. My baby picture, circle-shaped. My head is fairly, you just ask anyone, you tell you, it's fairly circle-shaped. Okay? If you think of the shape of a two-dimensional object, maybe another way you could think of it is, what if a ladybug walked along the edge of it? What if a ladybug walked along the edge of, for example, this stool right here, just walked along the edge of it? Or the outer edge of a Blu-ray disc. I made a little animation for you. So here goes the ladybug walking it. If that ladybug dropped a dot every step she took, or let's say she took a poop every step she took, okay? Would those dots be enough to define the shape of the circle? It might be, right? It might be able to tell you what the shape of the circle is. So we could take the poop and transfer it and we'd get the same shape, okay? We'd also know that each of these dots would be about the same distance away from the middle if we measured it. There's lots of things we can tell about it by that. Now, in fancy math terms, those dots are called loci or locus, okay? That's related to the word location. That's where the word location comes from, is it's part of this idea of locating something, okay? So when the bug walked across the surface, we could also say she was walking on a plane. We're going to come back to that in a minute. In a two-dimensional plane, we could think about single points. We could think about curved lines, straight lines. We could think about a large area within that plane, okay? These are some of the words that start coming out in geometry class. As well, we start bringing out other tools in geometry class. We start bringing out rulers. We start bringing out compasses. We start bringing out other things like protractors that we can use to not only measure in geometry, but to create stuff in geometry, to draw things, okay? Now, let's think about the simplest thing we can in geometry, a single point. Like if I said to you, right there, and I pointed, and I was talking about the end of my finger, I'm creating a 1 point. This has what's called no dimensions to it. You can't measure anything about it. It's just this point out in space, okay? Other than its position, we can't measure anything about it. But if I give you 2 points, we can create a line in between those 2 points, and one of the things we can measure is how long the line is. We can measure its length. This is what's called a one-dimensional object. It has one dimension to it, length. That's it. I can't measure its width or its height, just its length. If I add a second dimension, like a length and a width, now I have what's called a two-dimensional object, or a 2D object, okay? And I can measure other things about this. I can not only measure its width and its height, I could measure something called its area, which we're going to get into later. Area is something, if you were a painter, and this was the side of a house, you'd have to measure how much paint you'd need to actually paint it. If you were a fashion designer, and this was, you had a really square person, and you were going to make a dress for them, you'd have to measure how much material you'd be buying to fit that dress. Now, if we add a third dimension, or a 3D, then we add depth to our object, okay? I can't actually show you that realistically on a projector, but you live in a 3D world. A 3D world is the world we live in, okay? Now, in this particular object, there's even more things we can measure. We can measure area of all the sides of that object, and we can measure something called the volume, which is how much you can put inside of it. We'll talk in more detail about that in a later presentation about area and volume. But let's start with the simple stuff. What is the language that you're going to learn in geometry? This was the thing I tested you guys on in your diagnostic, and a lot of you struggled with this language. So let's look at the language. As I already stated, the simplest thing you can say in geometry is just a point. A point is just a simple dot in space. Because all that dot does is it gives you a location. Okay? Now this is the starting point though. So a dot can tell you things like, where does a line begin? Where does a shape begin? Like a square. Where does a circle begin? Where is its center? The dot is the beginning point of drawing and creating these objects. It starts with a dot. Okay? Now, if we have lots of dots out in space, we need a way to talk about different. So if I said to you, oh, that dot right there, which one am I talking about? Am I talking about that one or that one? You don't have any idea. So one of the things we do in geometry is we put labels on things. We put names on things. So the simplest way to name points in geometry is just put a letter there. Oh, if I say, oh, I'm talking about point F. All of you most likely just went right there to point F right now. If I said point D, you guys could probably pick it out of the points on there. Okay? So this is a good starting point because just like the dot-to-dot activities, you can now, for example, do things like join the dots, right? Because you now have a reference point of which is which as you start doing this. And geometry builds from that. So the point is the basic building block that geometry comes from. All right. The word plane in geometry is just the space that the dots are in. So here's a word that, again, you may not have connected to geometry. You might have thought a plane is something flying through the air, right? Or maybe if you're in Wood's class, you think a plane is that thing that shaves wood off of things. But a plane in geometry is just the space that the dot exists in. If you're working in geometry class, most likely your plane is your paper that you're drawing on. It's a two-dimensional flat surface that has an edge to it, right? The paper can't go on forever. But in the real world, the plane is much larger. It is infinite. In the real world of 3 dimensions, the plane is even larger, but we're not going to think about that. In math class, your plane is your two-dimensional space that you're drawing your points in. Okay, now, the next thing in geometry. If you have 2 points and travel between them, the shortest distance between 2 points is called a line. Now, that's actually a lie. This is not a line. This is what's called a line segment in geometry. It's called a line segment because it has a definite beginning and a definite end. This line starts and stops at 2 points. That's why it's called a segment. Okay? When you write this in geometry class, you want to be lazy about the way you write it. So the easiest way to write a line like this is to use the letters A and B, which you see down here. And then the easiest way to identify that it's a line segment is to just draw a line over top of it that looks like this. That's how you can tell it's a line segment. If it's a line, then theoretically it goes on forever in both directions. And the way we indicate that in geometry is to draw these arrowheads on 2 sides. The arrowheads indicate that this thing just keeps going forever, okay? Like the number line does. The number line goes on forever, okay? In geometry, we do this by putting arrowheads on the line over the 2 letters. That's called a line, whereas this one's called a line segment. Okay, there's one that's in between, known as a ray. The ray has a definite start, but then it goes on forever from there. Sort of like the bullet shot out of a gun. You know where the start of it goes, but then it just keeps going on forever after that. Okay? It's just an analogy. Okay? The way you draw this in geometry class is you use a one-sided arrow like this. That indicates what's called a ray, like a ray gun. Okay? All right. So here's the summary. The basic building blocks of geometry. The plane is the space that the dots exist in. The dots are called points. So there's point A. A line segment is a definite start and a definite end between 2 points. A line also has 2 points, but it goes on forever, and we indicate that with arrowheads. An array has a definite start, but no end, so it has 1 arrowhead on it. And then there are 3 different notations for writing that in geometry class. This was on your diagnostic, and you guys need to know these basic building blocks, or geometry questions are going to constantly confuse you. So you're going to need to work on practicing this. Okay? These are the building blocks. Okay, from these building blocks, we move to the next step. The next step after lines is, what if we have 3 points in a plane? Okay, so you know that we can have a line segment between A and B. The only way to travel to point C is to leave this line. There's no way we can get to C, like if this was a highway, there's no way we could get to C, if say C was a city, without leaving that highway. We'd have to jump onto a different highway. We could have a different line segment, but in other words, in order to get to point C, we have to leave the one-dimensional plane, okay? So we leave it to move to a 2-dimensional plane, and therefore we create a 2-dimensional shape. We need more than 1 line to get to point C, okay? Now, here's some more terminology. If we have 2 lines that are equal distance apart from each other, so any point along this line, you get to the same line with the same distance. These are called parallel lines. Parallel lines go on for infinity and never touch each other. They're always going to be the same distance apart. This is like, for example, parallel parking, or parallel universes, or parallel bars in gymnastics. That's where the word comes from. It means 2 lines that are the same distance apart that will never meet. Okay? However, if I tilt one of the lines, eventually there will be a point where they meet, those 2 lines. These are no longer parallel lines. They will eventually meet at some point. The spot where they meet is called the intersection point. So I'm going to mark it with a P. And at that intersection point, they form what's called an angle. The angle right here is the measurement that's the distance between the 2 lines at that particular spot. Okay? Angle is that distance between the lines at the point where they intersect. When you have 2 lines that intersect, you actually form 4 different angles there. I've colored them in different colors so you can see them. So this is what an angle is. Okay? Now, we need a way to name angles. So again, am I talking about this angle, that? Which of the 4 angles am I talking about? So there's lots of different ways that geometry teachers will do this. Some of them are very confusing. Okay? Sometimes they use just a letter. That's not confusing, like just X. Oh, okay, you're talking about angle X. Or Y, you're talking about angle Y. Some math teachers like to use Greek letters, like theta. See that weird circle with a line through it? That's called theta. It's a Greek letter. You're going to find that in some math classes that teachers are going to use a Greek letter for that. Okay? Some math teachers like to name it based on the points that create the angle. So here it's saying angle DPA. Notice I've colored it in. It's talking about the distance between point D to point P to point A and the angle that's formed between it. So let me try and draw something like that for you guys again. So this is kind of tricky. So if I gave you 2 lines, there's a line, there's a line. So they're lines, so I'm going to put arrowheads on them. That indicates that they go on forever. Now I need a way to identify the 2 lines. So I'm going to make a point right there, call it A. I'm going to make a point right there, I'm going to call it B. Now I know that's line AB. That's the line, AB. Now I'm going to identify points on this one. I'm going to say that's a C, and that's a D. So now I can say, oh, there's a line called CD right there. Now, I don't have to have them as lines. If I erase the arrowheads, they're no longer lines that go on forever. They're line segments, right? They have a definite start and a definite stop. So just over here, I would erase the arrowheads here as well and say, oh, that's just line AB and line CD. Oh, I've erased too much. There we go. CD and AB. There. Okay, that's pretty good. Now as well, because I have a spot where they cross, I should label this, which is the intersection point, I'll label it P. Okay? So now I've got a point just called P. There's a point P. Okay? So now if I'm going to talk about an angle, let's say it's this angle right here. I need a way to talk about that angle so it's different than, say, this angle. I need a way to tell the difference. So the easiest way is I could just put a letter there, X. Done. I now know which angle I'm talking about. But another way you could do it is to name it by its points. So I could say point D, that's this one, then go to point P, go here, and then go to point B. And that's the angle I'm talking about. DPB indicates this angle right here. The way you usually note this in geometry class is you make a little angle symbol like that. That's kind of a hard way to do it. The easier way would be to just use the letter, and I could say angle X. That's the preferred method I like to use to name angles, but you should be aware that depending on the class you get, the textbook you get, and stuff like that, geometry teachers might name it differently. Okay, so let's look at the other three. Angle DPB. Notice it goes here, DPB. That's that angle, or X. Angle BPC. BPC is this angle, also known as theta. Then finally, angle CPA is the same as angle Y right there. All right, don't overthink this, okay? Let's keep it simple. I don't want you guys to learn 50 different ways to do this. I want you to know this way. When you're looking at an angle, basically think of it as just a letter, okay? It'll be named just like anything is named with a single letter, and they'll usually use the angle symbol to describe that it's an angle, and you know you're not talking about a point or a line or something like that, okay? Now we need a way to measure angles. We need a way to put numbers to angles. We don't measure angles the same way you measure a line with distances. You measure angles because they're based on rotation, turning around. And they use a number called a degree for the measurement. Now, the degree uses that little round symbol, just like rotation, to indicate that it's a number in degrees. Okay? Now again, don't overthink this. Okay? Most angles are just described. Oh, sorry, I already had this one. Okay, the degree has different context to it as well. Okay? So for example, degrees are used for temperature. So that's a bit confusing. Am I talking about temperature or am I talking about angles? Well, don't overthink it. The word degree just means a small amount of something. In this case, it's just a small amount of rotation. So that's all it means, is when you're dealing with circles, you're dealing with angles, you're dealing with degrees. Your angle can be as small as 0 degrees and as large as 360 degrees, which is one complete rotation. All right, so let's look at a couple angles that are important. This is the 90-degree angle. A 90-degree angle from 0 to 90 indicates you've traveled 1/4 of the distance, or 1 out of the 4 spots. Then you can also travel halfway between a 45-degree angle, and then the different angles as you move around are important in a lot of ways. Okay? It depends on the kind of problem you're doing, but these angles have significance to them. Not all of them, like the one 135 is not that significant. 225, not that significant. But 90 is really significant, 45 is pretty significant, and 180 is pretty significant, as is 360. These are somewhat important to you. So the 190 is really important. That's what's called, it's so important that they've named it the right angle. Okay? And the way they draw a right angle usually is to draw a square, because a right angle indicates that two lines are what are called perpendicular to one another. Perpendicular lines are lines that intersect at a right angle. Okay? And it uses a special symbol because this is super important. This is the basis of building things that are square to one another. If it is less than 90 degrees, but greater than 0 degrees, it's called an acute angle. This is a word that, again, gets a little bit fancy in geometry, but acute angles are basically ones that are less than 90, but more than 0. So there's a whole bunch in there. There's 89 of them in there that you can use, okay? Then there are angles that are greater than 90, but less than 180. So in other words, angles that go beyond 90, but haven't reached 180 yet, those are called obtuse angles. So you have the word acute and obtuse, okay? Then there's actually a name for the 180. 180 is called the straight angle, okay? Because it's the angle of a straight line. A straight line, you think, doesn't have an angle, but that's why it's called the straight angle, okay? To measure angles, you need to use this tool called the protractor, okay? If you are in construction, there are even more complicated tools that measure angles. But in geometry class, we use this tool called the protractor for this. For some of you, I know you're a little bored because this is something you've seen before, but according to your diagnostic test, you guys didn't know this stuff that well. So here's the summary of this, okay? In summary of lines and angles, we have parallel lines, we have perpendicular lines, we have an angle measured with a protractor, indicated with a letter. It also has an intersection point between the lines. Then we have the right angle at 90 degrees. We have acute angles, which are less than 90. And we have obtuse angles, which are greater than 90. That's the summary here. These, again, were all on your diagnostic, and some of you were really lost on some of those questions. You need to know these words. From these lines and angles, we can build our basic shapes to wrap up today. Okay? So, our basic building block, a point, a plane, a line, and angles. From these, we build shapes. Okay? 2 lines alone can't build you a shape. Okay? Even 3 lines can't build you a shape unless we can connect it all together. We can form a chain here. So here are 3 lines and 2 angles, but it's not a shape. Okay? For it to be a shape, it has to close itself off and form a chain. No openings. Okay? And then we have a shape. This is the simplest shape you can create. 3 points, 3 lines, 3 angles. The word 3 is also known as try. Try and 3 means the same thing. Okay? Now, here's some other terminology we start to switch to. When we're talking about shapes, we often don't use the word line anymore. We use the word side. We can say that's that side, the 4 sides of a shape. We also sometimes don't say the word points. You're going to hear math teachers use the word vertices to describe the points, but we're talking about the same thing. A vertices and a points are the same thing. A point and a vertex are the same thing. So the simplest shape would be 3 points or 3 vertices, 3 sides or 3 lines, and 3 angles. The word 3 means try, which is why this thing is called a triangle. Then we move up to 4 points, 4 vertices, 4 sides, 4 lines, and 4 angles. If those 4 angles are all right angles, we have what's called a rectangle. By the word rectus is Latin for right, which means that's why it's called a rectangle. It's right angles. Okay? Now, if in that rectangle all the 4 sides are the same length, we have what's called a square. So a rectangle, every square is a rectangle, but not every rectangle is a square. All right, there's your 2 basic shapes, the triangle and the rectangle, and then something a little fancier, the square. This is the building blocks. From this, we can make more complicated shapes, like this one, the parallelogram, or this one, the rhombus, or the trapezoid, or the pentagon, or the hexagon, etc. We can keep building more and more complex shapes. In this case, we're adding sides, we're adding vertices, we're changing up the angles, even the octagon. Okay? Now, technically, all the shapes you see here, including, if I go back, the rectangle and the triangle, all of those shapes are called polygons. Okay? Poly just means many. So a polygon essentially just means many angles. Any shape with at least 3 sides or more is a polygon. Okay? So a polygon can be defined as a closed shape with sides, vertices, and angles in a 2D plane. What about circles? What about shapes like this with a curved line? Well, those are not polygons. Circles are not polygons, and shapes like that are not polygons. Polygons can only have straight lines. Okay? We are going to look at these curved objects in a later date. For now, we're going to limit ourselves to just polygons, just simple shapes built from our basic building blocks. So let's wrap it up. Here is what you need to know today. There is no method today. It's all language. It's all just these words you need to know. These are all the words you need to know as you start on geometry. So you're going to be provided with this. This is your to-do list. Okay? So let's quickly do it again, real quick. What is this in geometry? The space that exists. What's the word for that? The plane. What's the simplest thing I can put into a plane? A point, right? A point is the simplest thing you can put into a plane. If I have at least 2 of these points, I need a way to distinguish the 2 points, so they're very often just named. The next thing I can do in geometry that's so simple is travel the shortest distance between the 2 points, and that's called a line. Okay? Specifically, this is a line segment. It could also be a ray or a line itself. I'm not going to get into the specifics of that. We just have a line. Now, if we have a second line, so I'm going to make a C here. We have 2 lines, and they form a spot where they are connected at this, which is called the intersection point. That's the spot where they intersect. We form an angle. Okay? That's our angle. So from a plane to a point to a line to an angle, okay, we have the basic building blocks to then form a shape, and specifically that shape is a polygon, because a shape that can only be made from straight lines is called a polygon. And a polygon needs at least 3 points, 3 sides, and 3 angles. So from there, if I have 3 points, I can form a shape, a polygon. This specific polygon is called a triangle. This specific polygon is called a rectangle. And from there, I can build more and more complicated shapes. And that's it for